Okay, hi there. How are you today? We're looking at solving logarithmic equations in this video segment. And in this particular clip, we're focusing our attention on logarithmic equations that can be solved by rewriting them as exponential equations. So let's refresh our memory here. Remember that if I have the logarithmic equation, log base b of x is equal to y, that it's the same as writing b to the y is equal to x. Now this is true with a couple of caveats. One is, recall that our base has got to be greater than 0, okay? It cannot be 0 itself, and it cannot be something negative. Okay, so, and the other thing is our base cannot be equal to 1. And that usually isn't a problem in solving our equations, but it's something to remember. So using this idea is very helpful to us, especially if we have a logarithmic equation and we're trying to solve for x that's in this form. A logarithm is equal to some constant. Well, then let's just rewrite it as an exponential equation. Okay, so let's look at some examples. Examples here, we're going to start with log base 3 of the quantity x minus 5, and that whole thing is equal to 4. So we're going to go ahead and rewrite this as an exponential equation, and I think that you will see that, oh, that makes it just so much easier. This can look a little intimidating, but when I rewrite it, oh yeah, start with the base, raise it to the power on the opposite side of the equal sign, and then come back. Oh, I've got something very easy to solve, because then I just need to evaluate this exponent. 3 to the 4th, I think is 81, is equal to x minus 5. And then solving for x, I could just add the 5 to both sides. So I would have x is equal to 86. Okay, so now the only funky thing you need to keep in mind here is that, remember I made that little claim or disclaimer at the beginning that the base of our logarithm has got to be greater than 0. Well, it's also true that the argument of our logarithm has got to be greater than 0. Can't have anything that is negative here. So what I need to do, and this is really important, that when I solve for x, I need to take this solution, plug it back in, and make sure that I'm not generating something negative here. This can be negative as long as the argument itself is not negative. In this case, when I substitute the 86 in, what I'm taking a logarithm of is 86 minus 5, which is not negative. Okay, so I'm okay in this situation. All right, we will come back to that idea as we work these problems, and we may end up with a problematic situation or two. So let's look at this next example. Log of x minus 2 is equal to 0. Now, I put these two things right next to each other because I want you to distinguish between when you're taking a log of a binomial expression and when you're not. Notice that there are no parentheses here, and so right here we are taking the log of x. So we need to isolate the logarithmic expression by moving this 2. Okay, so we're going to move that 2 to the other side. Log of x is equal to 2. Okay, so now I can rewrite this in exponential form. Now when that base is missing, it is implied to be 10. So that's really the same as log base 10 of x is equal to 2. So let's write it in exponential form as 10 squared is equal to x. Oh, so then that must mean that x is equal to 100. All right, taking that back and making sure I'm not taking the log of something negative. Take that 100 there, and it's log of 100. Yay! Okay, so I am okay there. Moving along, we're going to look at ln of the quantity 2x minus 1 is equal to 0. Okay, so let's go ahead and rewrite this as an exponential equation. Now recall that the base of an ln expression is e. So this would be e to the 0 is equal to 2x minus 1. And what is anything raised to the 0 power? Why, that's 1 itself. So 1 is equal to 2x minus 1. Okay, now solving this linear equation, we would add this 1 to both sides, and I would have 2 is equal to 2x. And dividing through by the 2, we would get x is equal to 1. Okay, let's double check and make sure that we are not taking the log of something negative. Take that 1 back here. 2 times 1 minus 1, that would be 2 minus 1, or 1, and that is not negative, so I don't have to worry about that generating a negative argument for my logarithm. Woohoo! Very good. All right, moving along. Let's look at this equation here. Our logarithmic expression is this much of the left-hand side. So what do we need to do? We need to isolate the logarithmic expression and get rid of this 2. And we're going to do that by dividing. So log base 5 of 3x is equal to 4 divided by 2, which is 2. Okay, so now let's rewrite this in exponential form. So start with the base of the logarithm, which is 5. 5 squared is equal to 3x. I think 5 squared is otherwise known as 25. So when I divide both sides by 3, I would get x is equal to 25 divided by 3. And we can leave it just like that. All right, very good. Let's move on to the last 2 examples that we have. We have 5 plus 2 ln of x is equal to 4. And recall that this is the exponential piece, so we need to get rid of the 5 and get rid of the 2. Okay, we're going to do this in a couple of different ways. Getting rid of the 5, we would subtract. So we would have 2 times ln of x is equal to 4 minus 5, or negative 1. Okay, good. All right, and then we would get rid of this 2 by division. And so we would say ln of x is equal to negative 1/2. All right, so at this point we would rewrite this as an exponential equation. So recall that base is e. So we have e to the negative 1/2 is equal to x. Okay, so this is okay, but we really don't like to see negative exponents. And those rational exponents, oh, they're a little bit of a pain. So we're going to get rid of both of those. Remember that we can take anything that has a negative exponent, flip it down to the bottom, okay? So x here is equal to 1 over e to the 1/2 power. Okay, and that rational exponent would make it 1 over the square root of e. Both of those would be fine. And this is something positive, so we're not so concerned about our logarithmic argument being negative. All right, last problem. Okay, so in this problem, we have log base 4 of x minus log base 4 of x minus 1. And that's all equal to 1/2. Okay, so this is a little bit of an issue because we, in the past, have had a logarithm is equal to a constant. And here we have the difference of two logarithms is equal to a constant. So here's where the skills that we built on expanding and condensing logarithms come in handy, because I can rewrite this whole left-hand side as a single logarithm. Remember that we have a subtraction sign here, so our logarithm will be a quotient. So we will have log base 4 of x divided by x minus 1. And that all is equal to 1/2. Okay, so what I have here now, I can write as an exponential equation. Get rid of that log altogether by writing it as an exponential equation. So 4 raised to the 1/2 power is equal to x over x minus 1. Which we're looking good. Okay, we're looking like we can continue and finish this off. All right, so I think the 1/2 power, isn't that a square root? So this is really the square root of 4, which is also known as 2. So this is 2 is equal to x over x minus 1. And recall that we can get rid of a denominator by multiplying both sides by that denominator. So we're going to multiply this side by x minus 1 and this side by x minus 1. These would cancel, right? And we'd have x on the one side. So we would have 2x minus 2 by distribution is equal to x. 2x minus 2 is equal to x. Okay, so pull this x to this side, pull this negative 2 to this side, and I think we get x is equal to positive 2. Okay, so now if I substitute in here, we have one thing, and if I substitute in here, I have another thing. And I think that we end up with something good.